Another interesting application that we're going to deal with radian measure is angular and linear, or linear and angular speeds. You've probably seen things about linear speed or velocity, and that is that the speed, we're going to use the letter v as our variable for linear speed. Okay, so you probably know that linear speed is distance divided by time. And that just comes from the units, right? Like miles per hour. Miles are a distance, hour is a time, and so speed is distance over time, miles per hour, minutes per second, or I'm sorry, meters per second. However you want to list those units, it's always going to be distance on top and time on the bottom. And so this is a very common formula for speed, okay? I should probably define what the variables are, that's always useful. So in this case, v is speed, d is distance, and t is time. Now, of course, the units on the distance and the time will determine the units on the speed. And a variation of this formula is that distance is equal to speed times time, right? If you multiply both sides by the denominator, okay? Now, when you talk about an object moving in a circular path, right, or along a circle, so if you had some sort of object and it was moving in a circular path, then the angle at which it travels about the center determines an angular speed. So perhaps that object, like it could be a satellite orbiting the Earth, it could be the minute hand of a clock going in a circle, it could be a lot of different things. But the angle at which it travels versus the amount of time is called the angular speed. Okay, the angular speed is given in a similar way. You think about units, angular speed would be in radians per second or radians per hour. And so it's going to be in a similar angle over time rather than distance over time, because it's going to be in radians per time, radians per hour, or whatever. So angle divided by time. So the angular speed, and for angular speed, instead of using v, we're going to use a Greek letter omega. It looks like a W, or like a script W, okay? Omega equals the angle theta divided by time. So here's theta in the diagram. Of course, you have a radius. There's also an arc length that's covered by this called S. We've seen S before. And so omega is angular speed. Theta is the angle in radians. And of course, t is your time, same t, okay? Now, one thing I failed to mention is v is a linear speed. Linear just meaning it's a linear measurement like meters or feet or miles, okay? So this would be considered your linear speed, okay? Or distance, you could call it. Okay, well, your speed relative to distance, okay? And this is your speed relative to an angle. So there is an interesting relationship between these two speeds. So obviously, if you're traveling on a circle, you are tracing out a distance, like a linear distance. It's not in a line, but it's a linear distance. Like you could travel a certain number of miles in a circle, or a certain number of feet in a circle. So you still have that speed associated with it. And of course, the bigger the circle, the larger that speed is, right? So if you covered a 90 degree arc on a very small circle, you don't cover a lot of distance, but on a larger circle, the same angle, you cover a larger distance. So the radius is important in all of this. And so there's a relationship between these two. And of course, we already know the relationship that S equals r theta. The arc length is the radius times the angle. And so when you think about the distance, linear distance traveled, the distance is really the S. S and D are essentially the same thing, right? The distance traveled or the arc length are the same. And so in this scenario, D and S are equal to each other. And so our linear velocity, D over T, is really S over T. Okay, and then I could make a substitution because S is really equal to r theta. So it's r theta over T. Okay, so S and r theta. So D, S, and r theta all mean the same thing essentially. And that gives us our linear velocity or linear speed. However, also notice that theta over T shows up in the angular speed formula. And so if you think of this, if I peel off the r and think of it as r times theta over t, the theta over t portion can be replaced with the omega. And so r is real, or v is really r times omega. All right. So the linear speed is equal to the radius times the angular speed. All right. And so that's a relationship that we're going to be using now to determine, the linear speed of an object if we're given the angular speed, or vice versa. So if we now know that v is equal to r omega, if I know omega, I can find v. But then conversely, if I were to solve for omega, I know that omega is equal to v divided by r, right? I divide both sides by r. And so if I know v, I can find omega. All right, so these two formulas, really we'll probably focus in on the one on the left here, but they're interchangeable. These formulas are now going to be useful as well in solving some applications, which we'll get to in the next video.